All right, graphing our first example. First thing I'm going to do is I'm going to see if I can factor the numerator or denominator, and I can't. Okay, then I'm going to answer all these questions right here, and then I'm going to begin to build the graph. So down here in the space provided, let's talk about the domain. So when we look for the domain of the function, the domain means let's put our eyes on just the denominator for the domain question. So we're going to put x minus 2 cannot be 0. So the restricted x value is x cannot be 2. So if x can't be 2, that means our domain is all real numbers except for x equals 2. Then we're going to determine if those restricted x values give vertical asymptotes or wholes. Well, because x minus 2 doesn't have a factor of x minus 2 in the numerator, then we say the restricted x value. Okay, so this is considered number 2. I guess this is number 1. So x equals 2, then that restricted x value is actually a vertical asymptote. So the vertical asymptote is always x equals, and it's at x equals 2. I might go ahead and sketch in x equals 2 and begin to build this graph. So at x equals 2, let's go ahead and sketch in a dashed vertical line. So that means this is the break in the graph. We've got the graph over here, and we've got the graph over here on the other side of this vertical asymptote. There are no holes because the only restricted value is x equals 2, and that's already a vertical asymptote. Okay, so for number 3, let's go ahead and find the horizontal asymptote, or Bobbio Botno eats DC. So n is equal to, let's go back to the equation, n is 1 and m is 1. So n is equal to 1, m is equal to 1, n equals m, which means that exponents are the same. So we look and divide the coefficients. So the coefficients are 4 and 1. So the equation of the horizontal asymptote is y equals, because we have one, 4. The only time we don't have a horizontal asymptote is when we have bigger on top for Botno. Then that means no horizontal asymptote. All right, let's find the X-intercept and the Y-intercept. So come down here. The X-intercept is where y is 0. So let's go to the equation and let's let f of x be 0. All right, this is a little bit kind of new for us, and we may have solved one of these in the past, but for this problem right here, I would go ahead and put the 0 over 1, and I'm going to cross multiply. So 0 times anything is 0, and then 4x times 1 is 4x. So I get 4x equals 0. To get x by itself, since I'm multiplying, I divide out the 4's. X equals 0 over anything. When the 0's in the numerator, not the denominator, our answer is just 0. So remember, y was 0 and x is 0. So the x-intercept is 0, 0, the origin. Okay, for the y-intercept, remember we let x be 0. So let's go back to the function. Everywhere we see x, we replace it with 0. So f of 0 equals 0 in the numerator. That's what the multiplication gives, over -2. Well, again, 0 over anything is just, this will simplify to 0. So this is the point 0, 0, which is also the y-intercept. Okay, let's see if we can take all this information and put it together and see if we can draw a graph. If this isn't enough, remember we can always plug in different x values to the equation to see what the y's are to get additional points. All right, so I do know that I'm going to cross through the origin because that's my x and my y-intercept. Okay, I also haven't put in y equals 4 yet, and I probably should have done that when I first found it. So y equals 4, go up to y equals 4, and let's put in a dashed horizontal asymptote. And I might kind of highlight those asymptotes here. Okay, so what's happening is our graph is coming on to this grid either above or below this horizontal asymptote. But remember, as it approaches this vertical asymptote, it either has to turn upward or turn downward. Well, I have this point that I have to connect with, so I'm going to stay below this horizontal asymptote, And I have to come down here and connect with this origin point. And then as I continue downward, okay, I'm going to approach this vertical asymptote right here at x equals 2. So if I'm not sure about this graph and how it looks, I can always plug in like x equals -3. I can plug in x equals -1 for the x's to figure out what the y's are that go with them. But I have to connect with that point right there. All right, so what's happening on the other side of this vertical asymptote? And remember, the graph is leaving the screen hovering close to y equals 4. Well, what's going to happen is my graph's either going to come up from down here on the other side of the horizontal or vertical asymptote, but if it does come from down here, it's going to have to cross through the x-axis so that it eventually can turn and head out this way. The problem with putting the branch down here is that you have to cut through the x-axis, and I don't have another x-intercept. So that tells me that my graph is probably going to start from up here. I mean, it could start at the same, on the same side of the vertical asymptote at the same place. It didn't always have to be the opposite direction, like way up here. But for this particular graph and all that's present here, okay, this graph is going to come on this way. And as it approaches this horizontal asymptote, it's going to have to bend that way and finish to go off. That way, this branch never cuts through the x-axis because I don't have another x-intercept. Okay, all right. I might verify that this branch is good here. Let me plug in x equals -2 to the equation. So f of -2 means I have 4 times -2 over -2 minus 2. And if I go to my calculator, I would get -8 in the numerator and -4 in the denominator. This will simplify to +2. So let's see and confirm that if I have the point -2, 2, that I probably did draw this branch right. Just not quite on the points where I found, but that's okay. The basic shape is the same. Okay, let's just do another example. Example 2. First thing I'm going to do is I'm going to see if I can factor numerator or denominator, and I can't. They're already factored. So I'm going to go and find the domain. That's number 1. The domain comes from setting the denominator. We don't care about the numerator, we ignore it. Not equal to 0. So the restricted x value is 1. So is the restricted x value a vertical asymptote or is it a hole? Okay, well, remember that there's no common factor of x minus 1 on top. It has to be actually the same thing. So that means the restricted x value is actually your vertical asymptote. So for number 2, x equals 1 is your vertical asymptote. There's not a common factor. All right, so coming up to the domain, all reals but 1. And we have a vertical asymptote at x equals 1 with no holes. All right, I'm going to go ahead and get the vertical asymptote at x equals 1 sketched on here, labeled. Might highlight that. So this vertical asymptote divides the graph into 2 sections, to the left of the vertical asymptote and to the right. Okay, let's look for finding the horizontal asymptote. So going back to the equation, both degrees are the same. They're 1 and 1, so n is 1 and m is 1. So that's your EATS DC. Exponents are the same, divide the coefficients. So for the coefficients, they're both 1 and 1. So my horizontal asymptote is at y equals, always y equals for horizontal, x equals for vertical, y equals 1. So go from the origin up to y equals 1 and draw in the horizontal asymptote. I'm going to go ahead and highlight that. Okay, let's see now for number 4 if we have any x or y intercepts. So x-intercept means y is 0. So where f of x is, which is our y, we'll replace that with 0. So 0 equals x minus 3 over x minus 1. To solve this for x, let's put 0 over 1 and let's cross multiply. So x minus 3 times 1 is just x minus 3, and x minus 1 times 0 is just 0. Let's add a 3, so we get x equals 3. So our x-intercept is 3, 0. So we'll plot that. That's the only x-intercept. That's the only time we can cross the x-axis is right here. Now let's find the y-intercept. All x's are 0 in the original equation. So in the numerator, I get -3, and in the denominator, I get -1. The two negatives divide into a positive. So using function notation, I get f of 0 equals 3. So 0, 3 is my only y-intercept. So 0, 3 is right here. Right, is this enough information to help us put the curve on here, the graph on here, or do we need to plot additional points? Well, remember the graph's going to come on following this horizontal asymptote, but it's got to eventually hit this y-intercept. So I would think that the graph's coming on above y equals 1, and as it gets closer and closer to this vertical asymptote, it's going to turn upward so it can hit this y-intercept. When it leaves the y-intercept, it's probably going upward, extending off the grid, okay, going up to what we call positive infinity. All right, now we have to put the graph to the right of x equals 1. So either you have the branch up here coming down this way, or you have a branch coming from down this way, hitting this x-intercept and then curving kind of quickly and heading off the grid. Well, it's going to have to be coming from down here to have an x-intercept. So I've got this x-intercept, I got to hit it, and then I come out this way and bend and follow y equals 1. Had we put the branch up here, falling down, and then leaving and going off that way, I would have never picked up that x-intercept and touched it with my graph. If you're not convinced, choose some other x values, plug it into the equation, see what the answer is, and get those points to kind of confirm the graph that you think should be there based on what you've done. All right. Let's look at example 3. First thing I do is I look to see if I can factor, and oh, I can. The numerator doesn't factor, it stays as is, but this is a difference of 2 squares and it factors into x plus 1 and x minus 1. Notice we don't have an x plus 1 or x minus 1 in the numerator, so we have no holes. So both these restricted x values that we're going to get from these factors are going to be vertical asymptotes. All right, let's find the domain. So x plus 1 cannot be 0. I'm not sure why I put parentheses. And x minus 1 cannot be 0. Not really necessary. Since I already factored, I just set each factor not equal to 0. So subtract a 1. X cannot be -1, and x cannot be +1. So our domain, negative infinity, up to -1, etc. For number 2, okay, let's look at these restrictions. So x equals -1 okay, is a vertical asymptote because we do not have a factor of x plus 1 on top, and x equals +1 is also a vertical asymptote. So we have 2 vertical asymptotes. Let's go ahead and sketch those in. Remember, vertical asymptotes mean x, horizontal mean y. So we've got graph here, we've got part of the vertical asymptote here. So I'm going to go ahead and highlight those. So now we have 3 sections of our graph. The graph's going to come on the screen over here. It's either going to turn up or turn down. And then on the other side of this first vertical asymptote, the graph's either going to come up, getting close, being close to that vertical asymptote, or coming down. As it moves to the right, it's either going to have to leave the screen by going up closer to this second vertical asymptote or down closer to this second vertical asymptote. Then to the right of this second vertical asymptote, my graph's going to be contained over here somewhere. All right, so we have 2 vertical asymptotes and we have no holes. Okay, let's find the horizontal asymptote. So that Bobbio, Botno, eats DC, we've got 2 and 2. So the exponents are the same. So we compare the coefficients. So 2 over 1. So the horizontal asymptote is y equals 2. So go to y equals 2. You can dash in between here. It doesn't matter. It's just that we're really interested in the behavior of the graph as it comes on the screen close to y equals 2 and then leaves close to y equals 2 over here. The graph can cut through the horizontal asymptote, but it'll never cross a vertical asymptote. Okay, so here's your horizontal asymptote. All right, let's find the x and y-intercept, put those points on there, and see if we have enough information to conclude the graph. And I'm not sure you could leave the denominator factored, or you could go back to the original denominator. We'll see what happens when we solve this. Put 0 over 1, cross multiply, so we get 2x squared equals 0 times that denominator is just 0. To get x by itself, let's divide out the 2 first, isolate x squared. Now 0 over 2 is just 0. So when you bring in the square root on both sides, you're going to end up with x equals 0. So x is 0, y is 0. That's our x-intercept. It's also going to be our y-intercept. So y-intercept means x is 0. Two times 0 squared over 0 squared minus 1. Well, I can see that the numerator is going to be 0, so who cares what the denominator is going to be? Because that result is always 0. So 0, 0 is also our y-intercept. So it looks like the only point I have here is right here at the origin. Okay, so let's kind of tackle part of this graph over here to the left of this vertical asymptote. So the graph's either going to come on above this horizontal asymptote, turn upward, or the graph's going to come on below this horizontal asymptote, turn downward. But if we turn downward, we're going to cut through the x-axis, but we don't have an x-intercept over here. We have one in between these two vertical asymptotes, but not to the left of x equals -1. So I would just kind of predict that the graph is probably doing something like this. That way I avoid cutting through the x-axis. Let's tackle the graph in between these vertical asymptotes last. Let's tackle the graph to the right of x equals 1. For the same thinking over here to the right, should I come from down here near this vertical asymptote and then cut through the x-axis, leaving the screen this way? No, because then I'd cut through the x-axis and I don't have another x-intercept. So it looks like the graph is probably going to be coming down near this vertical asymptote and then approaching the horizontal and going off the grid that way. The only thing I have to figure out is what's happening in between here. And the best way to do that is to probably plot points. So what we're going to do is we're going to plug in -1/2 and +1/2 and see what kind of y's we get to determine how this graph is behaving. So let's plug in -1/2. So the function evaluated at -1/2 is 2 times -1/2 squared over -1/2 squared minus 1. So I know that that's 1/4, that's a half on top. I'd go right to my calculator. So I think the top is a half and the bottom is -3/4. I know that when I divide this out, my answer is going to be negative. I do have my calculator. Okay, so I would take +1/2 and divide it by -3 divided by 4. Make sure you use parentheses around your fractions. So I get -0.6 repeating, which is -2/3. All right, so let's plot -1/2 and -2/3. So -1/2 is here, -2/3 would be about right here. So that tells me that my graph is coming from down here, going to hit this point and then hit the origin here. Okay, so does the graph turn around and come back down? Or does this graph right here leave this origin point and continue upward? And remember, you can cross a horizontal asymptote, so don't be bothered by that. All right, so now I'm going to plug in positive 1/2, x equals positive 1/2. And what happens when you work this out, it's going to be the same result. It's going to be negative 2/3. So at positive 1/2, I'm going to go down to negative 2/3, and here's my point, which tells me this graph does turn around. It kind of looks like a parabola, those quadratics, and continues down this way, getting closer to that vertical asymptote. All right, let's look at example 4. All right, first thing I'm going to do is I'm going to look to see if I can factor anything. Kind of helps reveal to me if I'm going to have any holes. But I have x minus 3 and x plus 3. Neither of which these two factors are in the numerator, so both these restricted x values of 3 and negative 3 will be vertical asymptotes. So the domain. So x cannot be negative 3, and x cannot be positive 3. Okay, and both x equals negative 3 and x equals positive 3 are both vertical asymptotes. Haven't seen anything yet with holes. And I'll report the domain. Vertical asymptotes. And I'll go ahead and get those sketched. You can label them x equals negative 3 and x equals 3, but we've got them recorded here, so we're in good shape. Let's find, oh, we have no holes. Let's find the horizontal asymptotes. So n is 2 and m is 2. Again, the same thing. So divide the coefficients, 4/1, so y equals 4. Horizontal asymptotes always y, vertical always x. So let's sketch in y equals 4. I'm going to kind of highlight it so you can see it better. And let's find our x and y intercepts. Put 0/1, cross multiply. So 4x squared is 0. Divide the 4. So x squared is 0, but we know that when we do that work, x is 0. So we have the origin again as an x-intercept. And we know if the origin is an x-intercept, it's also a y-intercept. And we can only have one y-intercept, so if you don't want to show the work over here for y-intercept, that's fine. But it's still pretty good practice to continue doing it. Remember, the numerator is going to be 0, so the result is just going to be 0, 0 in function notation. All right, so let's plot that point. That's the only point we have. So it's very similar to this one right here. So I would say that we're going to have a branch here so that we can avoid the x-axis. All right, and then I'm going to have a branch here so I can again avoid the x-axis since I don't have any more x-intercepts. It's just right here. Does it look like this? Or maybe the graph is going up, or maybe it's coming down and slipping up this way. A lot of possibilities. So let's plug in some x values. I'll probably plug in -1 and +1. So let's see if I have room up here. So f of -1. So 4 times -1 squared over, I'll go back here. I guess I could plug -1 in this version too, doesn't really matter, but I've got a calculator. So on top I've got 4. This is 1 minus 9 or -8, so that's going to be -1/2. So that means that when I plot -1, -1/2, it's going to be here. So the graph's got to be coming up this way, Because if it came down this way, I'd have to come down here and pass through the x-axis. And then I'm going to plug in positive 1. It's getting kind of crowded. So f of 1, 4 times 1 squared, over 1 squared minus 9. This will again be 4 over negative 8, so that's also negative 1/2. So it just happens to look the same. Okay. All right. I do have 2 additional examples that'll be covered in an optional extra video if you need it. I believe on the, do I have holes on the other ones? No, I do on one. I have a hole on the other one if you want to see what that looks like too. I have a hole in one of the 2 additional ones, but that's just optional if you just need some more practice.